Hi, everyone. Welcome and thank you for joining us today for our live webinar, Policy-Driven Multi-Cluster Kubernetes Made Simple, presented by Mirantis and Nirmata. I'm Grace, and I'll be your moderator for today's session. Now, let's meet our speakers. I'd like to introduce our panelists and ask them to give a quick introduction. Lee, over to you.
Hey, everyone. My name is Lee Shea. Last name is spelled XIE. I run technical partnerships here at Mirantis. So my main charter is working with our Kubernetes partners like Dolis here from Nirmata and AI partners for Cordon, establishing relationships with them, doing technical integrations with them, and building what's called the Cordon catalog. I've been with Mirantis for half a year or so, and then prior to that, I was at VMware, also working on various Kubernetes OSS projects. So, thanks.
So my name is Dolis, and I'm a solution architect in Nirmata, and I've been in Nirmata for around 5 years now, and that's it. That's all about me.
Awesome. Thank you, Lee and Dolis. Let's now jump into the main presentation. Lee, I'll hand it off to you to kick things off.
Sounds good. Thank you, Grace, for that introduction. So today, our main topic of focus is how Kyverno and Cordon can come together and provide a use case for Kubernetes and the enterprise. And we want to kind of set the stage here by talking about real world challenges and real world use cases for these two products. And one of the ones that we came up with is really the balancing act of needing for enterprises today, of needing to fulfill the needs and flexibility and requirements of their developers and users who are bringing brand new workloads into Kubernetes. As well as those of the security teams and the platform teams to, ensure risk management, ensure that the platforms that developers are using are fully secure, compliant with various restrictions. And this has always been kind of like a clash between for security. I mean, a lot of the times when you talk about security, even outside of Kubernetes, the downsides almost always include like it's a hindrance. It kind of slows down development per se. It's inconvenient. It gets in the way of flexibility, right? But the upsides are, having good security, prevents your customers and your systems from being hacked. Right. So in that sense, really the best kind of security is the security that, kind of gets out of the way, is invisible to the user, is on by default, so they don't have to do anything, and isn't a hindrance. And we really can, hopefully throughout this presentation showcase that Cordon and Kyverno can help developers and platform engineers and security teams meet in the middle somewhere and have a solution that kind of accommodates both of those independently. And in this scenario that we've come up with, basically, and talking to a lot of the enterprises we've talked to, is like they really need an IDP platform that is very flexible and usable and self-serviceable by the developers, where developers can create their clusters anywhere. And, sometimes they may need to go create it on the cloud because there's new AI workloads and edge computing that needs to come into play. And when they do that, they also want to ensure, from the platform team's perspective, all the different policies, rules, and the ability of what images they can use are still in place, so that even though the developer gets flexibility, they're not completely rogue and causing potential gaps in security there.
And I feel that Lee has raised up an important point about how we are moving towards a more self-service fashion industry. And more, we are seeing that these Kubernetes applications are touched by various teams now. You see these applications are touched by security team, operations team, platform team, developer team. And all these teams have different requirements based on what they're looking for. For example, security team can have requirement that your pod run as non-root. Platform team have requirement, for example, they want to provide more self-service, namespace as a service, application as a service models. And operation team might have requirement, they want taints, tolerance, best practices, naming conventions, and developer just care about their application. So when all of these are like complex team dynamic, which is constantly touching your application. How do you make sure that you have all of that is secure and there is no impact or no vector for any of your hacker out there? This was an important, famous CNCF report that was published 2 years back, which talks about 93% of security incidents are because of misconfigurations. So if you bring out all the security incidents that you have seen in the news, in social media, here and there all the time, and if you drill down that what may be the reason, the number one reason is misconfigurations. So how do you avoid misconfigurations, and how do you make sure that while your clusters are running in Azure, AWS, on-prem, you have 50 different clusters out there. How do you make sure that you're still able to provide self-service to them, but also make sure that entirely they are compliant, there is nothing that is exposed, and there is no misconfigurations that might be potentially causing a threat to your security cluster?
All right. So here's the solution that I think Cordon and Kyverno can come into play to help reduce some of that attack vector and that the hacking or open holes in any cluster. So first of all, on Cordon's side, the Cordon platform allows you to use composable templates, cluster templates. And this is basically something that's defined by your platform team to give to developers to create golden Kubernetes clusters for their IDP. And this includes like a set of networking policies, security policies, and crucially, it can also automatically deploy Kyverno on any of the brand new clusters that are created by developers. And on the second part of it is that once those clusters are deployed, they're managed, and the entire life cycles of those clusters are managed directly through Cordon. So you have a super control plane that manages all the clusters. It has full visibility into any cluster. If somebody were to go into one of those clusters and try to remove Kyverno, the Cordon control plane will immediately put it back, as long with the different policies. And it will ensure that all those configurations that Dolis was talking about, any kind of configuration drift on an independent cluster will be reported back to the super control plane, and the super control plane will either take action and establish it back to what it was, because it's a declarative model, or it can be configured to warn the user that say, hey, warn the platform lead that say, hey, cluster A on AWS is, out of configuration. Are you aware of this? Do you want to, push it back? So that's on the Cordon side. On the Kyverno side, Kyverno effectively is able to enforce policy as code. So it does a lot of things like ensuring app armor, security context for the different pods, ensures that the image is coming from a trusted source, ensures resource limits. It also enforces labeling conventions. So some of your users may be labeling AWS with capital AWS, and then some users may do Amazon, call it Amazon, and it's able to enforce those conventions and say, hey, there's already a label called this, please use this instead. So that's a lot of network segmentation and other all the good security context that are available in Kyverno is available through the deployment in Cordon as well. So going to solutions continued, right? Like to break it down, what is the underlying benefit here? So the main thing is first automated policy deployment. So not only is Cordon deploying Kyverno, which is a necessary implementation of policies, but also the policies themselves. So your platform engineers can generate X amount of policies for all the clusters that are running AI, for example. So all the AI clusters have both Kyverno installed as well as various Kyverno policies that ensure maybe that anything using GPUs cannot be drained or pushed, or they get priority to resources. So that's just one example of policy enforcement there. Secondly, Kyverno itself on these child clusters and development clusters will act as a admission controller. An admission controller is something I'm sure a lot of folks are aware of in Kubernetes. It's basically the thing that allows validation of YAML and validation of pods to come onto the cluster. So before a pod or deployment can be scheduled on a cluster, it has to go through an admission controller. Kyverno will act as that admission controller and validate any resource that that pod needs, as well as mutate something if it finds that the validation isn't successful. those two aspects, I believe, really help address that balance I talked about in the beginning between flexibility, usability, and compliance and security. And just to take it one step further, right? Like when users feel a false sense of security, like when they think something is in place and it's not, that can cause even further problems. And in Kubernetes, the worst thing we can do is have security teams write up big policies and securities only to find out that they're not even in place. And then Cordon really is the meat that makes sure that all this stuff is in place and consistent throughout the cluster so that developers can focus on what they do best, which is creating code and leveraging and creating workloads. So let's talk real quick about Cordon and how it works. Cordon is a platform that manages multiple clusters, and it's a multi-cluster support platform that can create Kubernetes clusters, not only multiple of them, but anywhere as well. So they can create clusters on AWS, on Google, on Azure, on bare metal, on VMware. And what allows Cordon to do that is this left side here called cluster management. We call it KCM internally. So it's basically Cordon Cluster Manager. And it leverages open source resources to do this. So it uses things like CAPI for deploying, and the CAPI is fully open source to deploy clusters onto any of this infrastructure. So it's not only multi-clustering, it's also multi-infrastructure. And on the right side, we have something called, because we are already deploying these clusters, we have something called state management. And KSM, which is Cordon State Management, takes care of building all that entire service layer on top of the cluster. So a pure Kubernetes cluster doesn't do really too much, right? It's not consistent. It's just a place where you can put your workload. But being able to deploy a stack of applications onto that cluster that your applications need, such as monitoring, Kyverno for security, service mesh, Argo CD, all these tools being able to be deployed by Cordon, that makes it very, very powerful. And it also can consistently manage these tools as well. And in the middle here, we have the ability, it's called COF, which is the ability to observe and do FinOps. So it can say like, hey, which cluster is, performing, which cluster, your workloads being deployed on Azure could potentially cost less if you moved into AWS. All that analysis happens in the middle. Okay, so I think we're ready for the Cordon demo, which I'll go through real quick. So the first thing I want to talk about is in the demo is the Cordon catalog. Okay, so the catalog is effectively a place where you can see all the different applications and middleware that Cordon is fully compatible with and things that we've already tested. We have roughly 50 applications here these are called effectively service templates. And you can think of these as ingredients for a recipe that you can build into Cordon, that at the end of the day, a recipe can be like, you use Calico for networking, Kyverno for security, Nginx, and so forth, and then finally put your application on top. So that's a recipe. And these are the ingredients that you could put into your recipe. And secondly, we have infrastructure side. This is the side where we're talking about the cluster templates. This is all the different, we have 9 currently, where Cordon can push child clusters into. So we have Amazon, all the big hyperscalers, we have OpenStack, we have VMware, and we're going to be having bare metal very soon as well. Okay, that's the catalog. Just to see a live version of the demo, I have created a Cordon cluster here. It's called Mother Node or Super Control Plane. And on the Mother Node, the Cordon control plane, it's actually spawned 2 child clusters, one on AWS and one on Azure. So here's your AWS one, and here's your one on Azure. And that's 2 clusters, not that interesting. But in a real environment, enterprise environment, you can imagine Cordon managing thousands of clusters. Okay, this could be like this is a representation of potentially a lot more. So let's do something real quick. First, I want to show you that there's no smoke and mirrors, right? So we have virtual machines on my Azure cloud, and currently this Cordon management cluster has access to this Microsoft Azure cloud. And I only have the single deployment right here. We have Azure, the control plane, and Azure worker node. So it has a single Azure cluster with a control plane node and a, as you can see here, a single worker node. And so you can see the worker, right? So that's your Azure machine. we're going to add 5 more of these. Okay, I can show you how easy it is to do that. So I'm just going to hop into my terminal. Hopefully that's big enough. I'm going to go to CD Azure, and I'm going to k-apply-f. Bulk. I'm going to do a bulk deployment. I'm going to add 2, 3, 4, 5, 6. So 6 of these will be added. So I just do a quick refresh here on my UI, and you can see immediately, 5 additional clusters. I mean, this is clusters. This is just not just adding a bunch of worker nodes. This can, take days if you're using DIY solutions. Okay. So in about 10 minutes, that'll spin up, and I'll show you that also on the Azure side, you'll see more virtual machines come up. So I'm not just faking this demo here. The other thing I want to show while that's going, because that's going to take about 10 minutes, is we can also add services, right? So right now, I'm currently looking at my AWS cluster under applications. I really have just 2 applications. I have the CSI driver that lets me access the block storage on AWS, and I have an ingress controller. Let's add some additional services like we were talking about from the catalog. Okay, so that's also super simple in Cordon. So I go to CSI, and I'll do. I'll show you guys what this file looks like. So typically, if you're looking at a standard cluster template, you won't have any applications. You just have like the template you're using, this AWS standalone, the credentials you want to use, the infrastructure. You can talk about, where your region needs to be and your instance type, right? And then you can say like how many workers, what have you. Now, if you want to add additional services, like this one had Nginx already, but it didn't have Dapper, it didn't have kubectl, right? So the main difference is just down here between a standard template and something with some applications on it. Okay, so I'm going to apply and add a Dapper. Right now, you saw that there was no applications. We looked at it earlier in Lens, but I'm going to apply this one. It'll just make a different change, and you can see that Dapper is coming online immediately, and then soon kubectl is also coming online. And this is Lens, by the way. It's one of another tool that's created by Mirantis. But you can see, as you can see, it's like how easy it is to just kind of add services. I wanted to add Kyverno. I want to add more stuff. It's just a matter of doing that. If I can show you the difference between this configure YAML versus a one with just a cluster and some. So really, the only difference here was that we added Dapper and we added kubectl. Okay, and this might be okay. You'd be thinking like, oh great, you can add services to one cluster. That's not that big of a deal, right? Like, hey, I don't want to go add services to one cluster at a time. But Cordon has, as I mentioned earlier, has the ability to actually push these services to thousands of clusters. So instead of I did it in the single cluster way. I can also do it in the multi-cluster way, where I can make a multi-cluster service, and I can just basically say, apply these services to everything with this tag. And tag is just anything arbitrary. I can tag something like infrastructure AWS, infrastructure GPU, and basically every cluster that's tagged with that label will get those services. Okay, I'm gonna give this a second. It should be online now. So I'm gonna go to network, and I'm gonna go to ingresses, and I should be able to see Dapper dashboard and kubectl dashboard. So I should just be able to click here. I blow it up, and look, there's already the Dapper is fully installed along with its dashboard. I click on kubectl, and look, this is kubectl running on your cluster. Now you can evaluate your cluster, see how much savings you can get by moving workloads elsewhere. And this can be applied to thousands of clusters at once. And that's really the power of Cordon. Now let's go back and see if those Azure clusters, you see they're coming online one by one. They're all provisioning except for the last one. So what I'm going to do now as my final piece of the demo is actually go to Azure and show you guys the multi-cluster template. So I showed you guys a single cluster template, right, for adding services to a single cluster. This is the multi-cluster one. This is the one where I'm going to say, tell me any cluster that has infrastructure equals to Azure as that label, and put Kyverno 3.2.6 on every single cluster. And that could be 6, in my example, it's going to be 6 clusters, but this could be 1,000 clusters. And this could be, you could also have labels such that, match label infrastructure Azure, match label region Europe, and say like in Europe, I want to deploy Kyverno and I want to apply this particular European policy that Kyverno can use. So without further ado, I'm just going to do kapply-f multi, and this will showcase the ability to put it on multiple clusters at once. So this effectively will put it on every single Azure cluster, 1, 2, 3, 4, 5, 6, Kyverno. So looking at my Azure cluster, I have one of them at least. I go to applications. I say all namespaces, and I do a refresh. Should come up. Kyverno is there. It may just take some time to come online. Yeah, there you go. You see Kyverno? It's coming online. That's from the multi-cluster template. So that's the quick demo of Cordant. Obviously, there'll be a lot more. I also wanted to just showcase one last thing in Cordant. This is the UI that will be coming. It's not currently live yet. It's going to be in the enterprise version, but you can see like the different clusters you have deployed on a map. I mean, again, in my demo, it's just 2 clusters. You can see the different cluster templates. This is all the different kind of clusters, infrastructure we could deploy to: GCP, remote, vSphere. And then under services, we can also browse directly to the catalog, directly from our UI. So yeah, very interesting stuff. And I think that's it. Let me go back to our presentation, and I'll let Dolis take it from here.
Perfect. Okay. So yeah, I think what we saw was now with Carbon, what you can do is you can roll up 20, 50, thousands of clusters, and then you can add add-ons on them, and then you can deploy whatever applications you want. Lee showed us how he deployed Kyverno, and then that's somewhat you need a policy enforcement so that when you're deploying thousands of clusters, how do you make sure that all of them follow the same naming convention? It doesn't have equal amount of nodes. The configurations are all right. And that's where Kyverno plays a role. It makes sure that all of that is, all the policies, whatever you apply, and all the security practices and best practices are maintained while you're deploying these clusters. Before we dive deeper into Kyverno, a little bit about what Kyverno is. So Kyverno is an open source CNCF tool, and this has been an incubated project, been there for 3.5 years. It's been adopted by a lot of organizations, and we do have the largest policies in the open source community. So it's like 450 and stuff. And the key capabilities of Kyverno is that it can not only just validate, but it can also mutate. That means it can patch your existing resource. For example, if you have a use case where you want to patch a label or you want to patch an image is coming from an outside registry, and you want to automatically add a patch so that it is not being pulled from a local public repository, rather from your own repository, you can add a patching mechanism there. So Kyverno can do that using mutate policy. Kyverno can also generate resources. An example of that can be if you have a namespace, you might have a use case that whenever there's a namespace created, create request, quota, or create RBAC so that developers can have their own namespace. You can provide namespace as a service to the developers. So Kyverno can do that. It also has cleanup policies, and the way cleanup policies work is you can actually create cleanup policies and ask them to clean up resources based on a TTL label. So it can be like, okay, we need this app for 2 days, and I want after 2 days, policy should clean up all the resources. And now you can give these applications as service to your developers. Kyverno can have that. Or it can also use using policies, it can verify images. So you can plug Kyverno into your supply chain use cases where you're verifying images with your signature, attestation, and other things. Now, all of this is something either you can do in your shift down cluster or a shift left cluster. That means you can scan using all of this in your CI/CD pipeline using Kyverno CLI, which is a dry run rather than installing Kyverno on your entire Kubernetes cluster. And the policy is when you're writing a policy, you do not require a programming language. It is basically just like a pod YAML. So using basic labels and basic logics, you can create a policy and you do not need a huge learning graph to deploy a policy. So let's dive into what are different use cases based on what I was talking about. We can have validate, we can have mutate, we can have cleanup. So now you can, in a way, plug in Kyverno for different use cases. You can have FinOps practices like having a policy which can make sure that it's deployed in a particular region, the node doesn't go above a certain limit, the node doesn't have a different type. and stuff like that. So there are different use cases, and you can actually enable a lot of automation use cases using the generate and mutate policy of Kyverno. A little bit about Nirmata, which is you can see on a screen, is Nirmata is creator of Kyverno. So we created Kyverno 3 years back, 3.5 years back, I think. And now we have donated it to CNCF. So it is an open source CNCF tool, which is backed by Nirmata. So let's do a quick demo of what you see and how does it work. So Lee has already installed, you've already seen how you can have Kyverno in a Cordon cluster. So you can think of this is one of a tenant cluster which can be created by Cordon. And I do have already Kyverno running on it, just like Lee showed. And I don't have any policies right now. But what I want to do is I do have some policies, and a simple one is validate label. So what does this policy do is basically it's going to validate a certain label if those are present on your application. Now let's look at what this policy look like. So over here, as I said, this is a simple YAML, a pod YAML. There is no such programming language or some difficult syntax you have to go through. So it's a kind, just like in Kubernetes, you see there is a metadata, there is a name. There are some annotations which are kind of making the policy lengthy, but they're just merely annotations, which tells you what this policy is doing. And you can define the title, the severity of the policy. And then here there is a rule which says that it's checking for a label and it is applied on a pod. So all this, it will be checking all your pods in your cluster. And this is a message which you'll see in your policy reports whenever this is getting enforced. And if your developer is not able to deploy that, you'll be seeing this on the screen saying that this label is required. And if you look at the pattern or the logic statement from line number 28 to line number 31, what I've overdone here is I've just copied the syntax of the pod that I want to verify against, or a deployment or any other resource, and just copied and thrown it in the policy. So it's checking a pattern under your pod metadata under labels and just making sure that this label is present. So now what you can do is you can copy any pattern from any of your resources and just throw in the policy and it will check that pattern. So it's quite straightforward. Now let's see what it looks like. Is I'm going to deploy this policy. Okay, apply is perfect. And I see that this policy is ready and it is all good. So now once you have a policy deployed, and I'm doing this in enforce mode, but you can also deploy it in audit mode. That means you're not blocking anything, but you see what's going wrong in the form of policy reports. So here I've enforced it. That means anytime when anybody is deploying an application with no label, just running a pod, it will block that pod saying that this validation is not possible. There's a validation error saying that the label is required, and it is checking at metadata label. So it tells and gives you all the information that a developer or a user needs to deploy their application using the best practice. You can change this to audit mode, as I said, and then Kyverno will not block or have some quick restriction in terms of blocking the pods. Rather, Kyverno will give you an entire report of what the violation looks like in the form of a policy report. Now, let's look at a second policy, which is a mutate policy. And I'm going to just go in here, or probably go here and check that. So this is a mutate policy, which is a contradict of what I showed in the validate policy, where a validate policy was validating for a label, but a mutate policy is adding a label. So now think about all the things that you want to enforce, but take a different turn on that same concept. And sometimes if you want to validate, that's a good one to validate certain configurations and make sure that all of that is good. But you can also mutate those configurations in the pod. So if you want to have a best practice to have security context in your pod, you can use a validate policy and validate that, make sure that pod is not running as a root user. But you can also have a mutate policy and add a security context, mutate every application out there, so that you're not seeing any enforcement, you're not seeing any violations. Rather, you're fixing that by mutating it. So that's an entire different use case over here, where I'm adding a label, and I'm adding a label called foo and bar, which is like a simple label. And it does the same thing where I'm adding a label in a pod service config map. So you can add any security, any Kubernetes objects in here and define your mutating rules. So if you look at the mutating rule as well, done nothing fancy. I've copied the same syntax in the pod, not even used most of my mind, just copied there, pasted it over here, and this becomes a muted policy. So, so let's see how does that run. So I'm going to delete my old policy and I'm going to apply a mutate label policy. And now I'm going to run the same pod. Since this time we don't have the validate policy, this pod will go through and it is saying that it is created. And I'm going to just check if there is a label present in here. And if I go up above, you would see that there is a label present called foobar. So now think about all the automation use cases and all the mutate use cases that you can enable in your infrastructure using Kyverno policy, and do not just restrict it to the validation of a particular resource. So that's about a little bit about what Kyverno is and what capabilities Kyverno has to offer. Now, if we talk a little further about it, and what we are seeing in the industry is Kyverno is good in terms of scanning it. Kyverno is good in terms of detecting what the violation looks like. But what do we do with all those violations? You can clearly install Kyverno in your cluster, and you can see thousands of violations coming up, which kind of gives me an anxiety because now I don't know how to remediate these violations, how to fix these violations. If you have 100 applications, 30 developers, and thousands violations, think about the back and forth, the friction, the analysis that I have to do, and I just don't know how to figure all that out. So that's where Nirmata steps in and helps you to fix those violations. So Kyverno is good in scanning it, flagging it, making you aware that what exactly is going wrong in your cluster, which is good. If we don't have any admission controller, we wouldn't be at a stage where we don't even know what's happening on your cluster. But once you understand, okay, this is a problem, what do you do next? That's where Nirmata steps in, where Nirmata helps you to not only just flag that, but take it ahead of that. So when you do the scanning and when you flag it, Nirmata can send those reports to your developers. They can assign it using Jira, ServiceNow integrations. You can also fix them, give them a remediated YAML so that developers know that, okay, this is something that I need to add, because let's be honest, developers are not Kubernetes savvy, and it is not that they're expected to know everything about Kubernetes. And that's where it includes the complexity of fixing all of those issues. Nirmata helps you to analyze that, gives you some recommendations, tells you what the time series graph looks like, where how many violations were there last year, last month, and what the progress looks like. So just going quickly into what it looks like, this is what the remediation looks like, where it gives you like, this is the memory and this is what it is supposed to be, or this is a security context and this is what it is supposed to be. And it gives you some remediation recommendations as well. It tells you in terms of what your violation journey looks like. It gives you some suggestions. It gives you an entire one plain class to understand what these violations are and take actions on these policy reports. Either fix them, that means remediate them, either give an exception, and Nirmata does have an exception workflow, either troubleshoot why these applications are not up or what Kyverno is doing, how Kyverno is blocking it, or integrated with third-party system just to make sure that all it fits into your enterprise workflow. So yeah, I think that's all about it. I'm going to take a pause here and see if we have any questions. So Grace, over to you.
Thank you, Dolis. Okay, thank you both for the insightful presentation. Let's take a look if we have any questions posted. All right, we've got one question. The first question and the last question is, how does Kyverno differ from other policy engines like OPA, Gatekeeper, especially in the multi-cluster context? Dolis, maybe could you walk us through the key differences and where Kyverno really shines?
Yeah. So how does Kyverno differ from other policy agent is Kyverno, of course, it's out there, OPA or any other policy agents are admission controllers, and Kyverno is also an admission controller. But Kyverno doesn't have just the validate policy. It has more than that. It can also help you, just like I showed, it can help you to mutate it. It can help you to automate a bunch of the other use cases by generate policy, cleanup policy, verify image policy. We have also launched something called as Kyverno JSON. That means you can also scan your JSON payloads in your CI/CD pipeline. And you do not require a large learning graph. That means you do not require a programming language. It's simple YAML that I showed you, so you can easily plug in. And it's very Kubernetes native and it's very Kubernetes friendly. So that's how Kyverno differs from other policy engine out in the market. And I think it really depends upon the use case and what you want to achieve here. It's more like an apple to orange comparison where you might be looking for an apple, so you want an apple, and if you're looking for an orange, you're looking for an orange. So it really depends upon the use case. But if you talk on the higher level, that's what the comparison is between the two.
Got it. Thank you so much. That's super clear. Thank you. Don't forget to join us again for our next webinar, Simplify and Secure Multi-Cluster Kubernetes with Cordant and Calico, happening on July 2nd. You can find the link in the resources section. Thanks again, and we hope to see you again, and have a great rest of your day. Bye, everyone.
Thank you, folks.
Bye,
Bye-bye.
everyone.
Thank you.
Thanks.